Good evening. Let's say that we've got this integral from -1 to 4 of the absolute value, let's say 3x minus 2. And we want to evaluate that. So first thing is, we'll check out the graph of this thing. So 3x, the absolute value of 3x minus 2, let's see. It's just kind of a V shape going through here. I'm not being extremely careful, except I did draw that in the slightly wrong spot because the x-intercept is here. Okay. Now what I want to do is split this into two pieces then, okay? Because with the rest of your functions that you've had, with polynomials and stuff, they're nice and continuous, they're differentiable everywhere. They don't have any of these little sharp corners where things go weird, okay? So I'm going to split this up into two parts, and from -1, that's what I had, right? Yeah. So I'm going to go from here to the corner where that x-intercept is. I'm going to look at that area. And then I'll go from, what did I say? 4 was the top end. Okay. 1, 2, 3, 4. So then I'll do this area separately. Okay. Now, if I'm going to do that, then I just want to turn this into linear equations, right? And this first one over here would just imagine extending it down or whatever. It's just a straight line, right? So you could write the equation of the lines and stuff like that. But it's just, if we look at y equals 3x minus 2, all that means is we have two equations. Y is either equal to 3x minus 2, okay, or perhaps y is equal to the negative of that. So that'd be negative 3x plus 2. Okay. So this is the y equals negative 3x plus 2. This part of it is the y equals 3x minus 2. And I can just identify that because the slope for the one is negative, so I know it has the equation with the negative slope. And I'm just going to add those two together then. So for the part on the left, we're going to have a -1 to 2. Now to find out where that little v is, okay, actually I better check instead of just trying to use my little mind here, is that when is 3x minus 2 equal to 0? And I know I've got that in the wrong spot then. So 3x is equal to 2, so x is 2/3. Okay. So that's actually when x equals 2/3, and so I know I have it graphed at the wrong spot, but I'm just using the picture to separate out the pieces. Okay, so I'm going to go from -1 to 2/3, and it's negative 3x plus 2 dx. And then I'm going to take the other half of it, that right-hand side, and that's going to go from 2/3 to 4, and that'll be 3x minus 2 dx. And now I have two integrals with just linear equations that I know how to deal with, right? So this is going to be negative 3/2 x squared plus 2x when I do the antiderivative. Evaluate that from -1 to 2/3. I'm going to go ahead and do that while I'm thinking about it. So stop moving. So that's negative 3/2 times 2/3 squared plus 2 times 2/3. That minus and negative 3/2 times -1 squared plus 2 times -1. that's 2/3 minus what do we have? Well, -3/2 minus 2. That'd be 4 7/2. That part will be -17/6. Then we have to do the other half of it, of course. Okay. So that'll just be, what, 3/2 x squared minus 2x. We'll evaluate that at 2/3 and 4. So evaluating those then. So that's 46/3, and we want to add those two things together then, because it's that plus that, right? And let's see. Wait a minute, something is not right. Okay, here's what I know. I'm thinking I might have messed something up. Because this area here that I have in red shouldn't be negative. That should have been a positive 17/6, but let me double check. We got 2/3 plus 7/2. That's 25/6. So I knew I messed something up. I typed something in my calculator wrong there. So that's 25/6. And when I add those two things together, then I'm going to have the area that's all under that curve there. So that's 39/2. And that would be my area. So hopefully this will help. Have a wonderful evening.